Mechanism. Two possible mechanisms depending upon the condition of the reaction have been proposed. Ionic mechanism. When it operates when the reaction is carried out in solution, it has been suggested that an atom of sodium reacts with an alkyl halide to form an alkyl sodium compound having a carbanion character. The alkyl sodium thus formed provided the nucleophilic alkyl carbanion, which displaced the halide ion from another molecules of alkyl halide by SN2 mechanism, resulting in the formation of an alkane. This mechanism also explains the formation of side product, for example, ethyl iodine or treatment with sodium metal in the presence of ether given butane as the major product and ethane as the side minor product. बाद में सेकेंड मेथड है फ्री रेडिकल मैकेनिज्म. कहता है when the reaction is carried out in vapor phase, it can take place by a free radical mechanism. Sodium metals first react with alkyl halide to form alkyl free radical, which make couples or disproportion to form the observed product. Rx plus Na arrow R radical plus में NaH, R radical plus R radical is equal arrow R dash R alkane. R means CH3 CH2 इधर से कोई भी group. Coupling reaction yield a higher alkane C2H5 radical plus C2H5 radical arrow C2H5 bond C2H5 butane make. This propagation reaction form alkane and alkene. Mechanism. The alkyl group of alkyl lithium displaced halogen from copper alkyl to give alkyl copper. Alkyl copper react further with alkyl lithium to form the dialkyl cuprate anion. The alkyl halide undergoes nucleophile attack by dialkyl cuprate anion to form an intermediate which is unstable and thus fragment to give product. The Frankel method. When alkyl halides are heated with zinc in an inner solvent, higher alkanes are formed. Mechanism. The reaction is believed to proceed through the following step. Ri plus Zn arrow Rzn I. Next step 2Rzn I arrow R bond Zn bond R plus ZnL2. R single bond Zn single bond R plus 2Ri arrow 2R single bond R plus ZnL2. Form alcohols. The alcohols give corresponding alkanes on reaction with excess of Hi red phosphorus. The function of the red phosphorus to react with the I2 to give PI3 and thus make the reaction more forward. The higher alcohol give lower alkanes or reaction with concentrated HNO3 following by NaOH The lower alcohol give higher alkanes on reaction with Cl2 light following by Hughes reaction or Corey-Hauser reaction. From ether, the ether on reactions with Hi red phosphorus give corresponding alkane. From amines, the amines on reaction with HNO2 give alcohol with further react with Hi red phosphorus give corresponding alkanes. From nitroalkane, the nitroalkanes on reactions with Zn HCl give amines which can be converted into corresponding alkane on further reactions with HNO2 ethyl phosphorus from carboxylic acid by Kolbe electrolyte method. When a concentrated aqueous solution of sodium or potassium salt of a fatty acid with electrolytes, higher alkane is obtained and so below. Mechanism: the reaction is believed to take place through the following step. Both anion acetate and hydroxide ions will migrate towards anodes since the discharge potential of CH3CW negative is lower than the HO negative. Therefore, CH3CW negative ions are preferably discharged at anodes. HO negative remain in the solution. At cathodes, since the discharge potential of H positive ion is lower than the of Na negative positive ions, therefore H positive ions are preferably discharged at anode. Na positive remains in the solution. Limitation: this method is suitable for the preparation of a alkane with even number of a carbon atom. Method cannot be prepared by this method. Methane cannot be prepared by this method. When a mixture of sodium or potassium salt of two different carboxylic acid is used, a mixture of three alkanes is formed. By heating with the soda lime decarboxylation. When the sodium salt of a carboxylic acid is heated with soda lime NaOH plus CO, carbon dioxide is lost and alkane is formed. The process of elimination of carbon dioxide from a carboxylic acid is called decarboxylation. Decarboxylation is a method of preparation an alkane with one carbon atom less than the starting carboxylic acid. For the lower homologous, the yield of alkane is good, but for higher homologous, it is poor. Mechanism: the decarboxylation of carbonate ions involve the formation of an alkyl carbanions R negative which take up a proton to form a alkane. Decarboxylation is facilitated by the presence of electron withdrawing groups such as the lower carboxylic acid gives the higher alkane on reaction with NaOH followed by Kolbe electrolysis. Second, HI phosphorus followed by halogenation and Wurtz's reaction. From acid derivatives: the acid derivative ester acid, amide acid, halide acid, and hydride on hydrolysis give carboxylic acid which on further reaction with Ni react HI red phosphorus give corresponding alkanes. NaOH CO heat give lower alkanes etc. The acid amides can give lower alkanes on reaction with Br2KOH Hofmann bromoamide reaction followed by reaction with HNO2 HI red phosphorus heat. From aldehyde and ketones: the aldehyde and ketones on reaction with the reducing agent ZnHG HCl Clemmensen reduction or NH2NH2KOH Wolff-Kishma reduction or HI phosphorus give alkanes. The aldehyde and ketones give lower alkanes on reaction with concentrated HNO3 followed by the NaOH CO heat. The aldehyde and ketones give higher alkanes on the reactions with concentrated HNO3 followed by NaOH Kolbe electrolysis. From Grignard reagent: the reaction reagent on hydrolysis with H2H positive give homologous alkane. The Grignard reagent on reaction with aldehyde ketone followed by hydrolysis give alcohol which on further reaction with HI phosphorus give corresponding alkanes. The Grignard reagent on reaction with CO2 followed by hydrolysis give carboxylic acid which on further reaction with HI phosphorus gives corresponding alkane. Cracking: The process of converting of higher hydrocarbon of petroleum into lower hydrocarbon by strong heating is called cracking. Example: the N-octane on strong heating breaks down as following: C8H4 plus C2H4, or second, C4H10 plus C2H4 plus CH4 plus C. It is evident that cracking involves the breaking of carbon-carbon single bond as well as carbon-hydrogen bonds. The reaction follows a free radical mechanism. The nature of product formed on cracking of alkanes depends upon the structure of alkanes, the pressure under which cracking is carried out, and the nature of catalyst. The cracking process is of prime importance for the manufacture of gasoline from higher boiling fraction of petroleum. It is also used for production of oil gas from kerosene, which is used in the laboratories. Changing occurring during cracking. During cracking, following important change take place. State change alkanes are isomerized into branched chain hydrocarbons. Saturated hydrocarbons are converted to unsaturated hydrocarbons. Cyclization of aliphatic alkanes may take place. Cracking leads to the formation of a mixing of a large number of hydrocarbons, all having lower boiling points than initial alkane. Note: the lower alkane can be converted into higher alkane by Bourgeois reaction by Kolbe electrolysis. The methane cannot be prepared by Bourgeois reaction by Kolbe electrolysis. The methane can also be prepared by hydrolysis of aluminium carbide and beryllium carbide as preparation of a alkane all complete.